Hey everyone, it's March 25th, 2018. This is the video that I'm going to actually run that 2-scale Earth-Moon model that I've been talking about. The other videos are linked below, the ones relevant to this topic. Those of you who have watched them already know what's going on. The actual observations that I'm going to take of the moon in the sky are going to be this upcoming weekend, the night of the 30th and the 31st. Let's just hope for no clouds because we're going to be up north. This is the intro. I'm actually recording this. I've already started doing stuff, but I'm still going to put this first. We have beautiful sunny skies today, but it's not as warm as they predicted it was going to be, which is fine. It's not like we have snow on the ground or high humidity or anything. So this is a good video if you want to set up, like, you want to make predictions about something. I mean, in this case, I'm doing the moon through its orbit relative to Earth as during one night, but I'm building this 2-scale model to make predictions, and then I'm going to take that footage and compare it to my actual observations next weekend and see how close they match up. Now, I know there's going to be a margin of error. I've talked about this before because my model is not perfect, and those of you who've been watching know that my Earth globe, which is basically a beach ball, is a little bit narrower than it was supposed to be, but the camera will be 4 inches out. That'll compensate for that. So I do expect margins of error, but they shouldn't be that big. I'm thinking plus or minus 5 degrees at the most. But anyway, I guess that's it. Let's get started. Okay, there's the date and time, and I am setting up for a 2-scale model of the Earth-Moon system for observations I plan on making basically a week from today. Now, my distance on the tape measure here to the bucket, which is what I'm going to use as to hold the globe of the Earth, 60 feet. This is intense. He says engineer scale. It's intensive feet, not inches. Alright, I'm going to do this and record the height, because remember my globe is about, so we have about 17 and a half. That's good enough. The lip comes up a little bit, so we have 17.5 inches as bucket height, and we know the diameter, or the, actually, yeah, we'll just do diameter of my Earth globe is equal to 16.0 inches. This is all in inches. These, I'm going to use one of these. I got 5 of them because I was going to do 5 individually so I wouldn't have to move it, but I figure it might be more practical for me to move it. So what I'm going to do is I'm going to take this in the basement, cut that off a little bit. Alright, then I'm going to measure, I'm going to put black ticks for every 1 foot increment. And I'm going to put a flat base on top. This is where my moon will go. This will be standing up in the ground like that. That's where that'll go. So, I'm going to go do that now. Okay, before I start cutting that board I just showed you, I need 5 observations. This is the beginning of that tape measure, where the observation, where the globe will be. The globe's going to be down at that end at 60 feet. This is where that stake with the moon is going to be. It's going to be observation 1. Now, remember, I need 5 blocks. Well, that's going to serve as my first. And they need to be 1.75 feet apart, or about 21 inches. So, look at a little sliver there. I don't expect this to be perfect. I mean, there's going to be some error, which I'm going to go over later. But this shouldn't be significant error, because that's going to represent moonrise. That's going to be 3 hours after that, 3 hours after that, 3 hours after that, and that should be around moon set. So that's the distance to scale that the moon's going to move in its orbit during the course of my observations. So now I should start cutting that board. Okay, so now we're in the basement. Here's that board. Now, this is scrap that from behind work. They actually did say I could take these. They want them out of there anyway. But I need to cut a piece of that that's like that. I'm just going to randomly cut it with my saw. Alright? And then I got to cut this just out like here, random. The measurement doesn't matter because I'm going to compensate for that. Then I'm going to put this piece at the top of here, all right? And when I'm just going to use one screw, and when I do that, then I'm going to measure out 1 foot increments and leave space on the bottom for where I'm going to drive it into the ground, like the depth I want, and then it'll be 1 foot from that. Remember, my moon needs to be 3.9 feet above my ecliptic. All right, and I'll show you that later. Okay, cut the bottom off that stake. I just arbitrarily cut it, and I cut that support piece off the top of that board. And now what I'm going to do, well, I already drilled the hole in here. The hole in here, I'm going to hand screw this 2-inch interior screw. So I will assemble that right now for you and show you, and then I'm going to draw the lines, and then I'll show you, I'll explain what I'm doing. Okay, so there's my screw. This is going to be the top. This is where the moon globe is going to rest upon. Now, I measured this out. It's close to 80 inches. It doesn't need to be exact, because now what I'm going to do is I am going to just draw an arbitrary line here. See, I've got more than enough, because remember, I need to be 3.9 feet above my ecliptic, but my ecliptic's going to be above the buckets that I measured earlier. So I need more than just 4 feet of this. Plus, I got to drive some of this into the ground. So probably going to put my mark there. Then I'm going to measure and put 1 foot tick marks all the way up. And so I'll have a reference when I actually set this up. Okay, there's my 1 foot tick marks all the way down to 6 feet. Right there, right? And that's from the top of the board. So that's from here, because the height of this needs to be taken into account too. It's not from the top of this. Okay, so how's this going to look when it's in the ground? First of all, I just want to say Sarah's sanding the tables very nicely. I got to be careful so I don't mess them up. She'll kill me. But basically, this is what it's going to look like. So it's going to be into the ground up to right about there. And then it's going to go up, and the moon is going to be setting right on top there. Now, I just did the math. Here's my calculations. I'm not going to go through them. You can if you want. So my bucket, my ecliptic is essentially going to be 2 feet 1/5 inches up from the ground, which is 2.125 feet. If I subtract 6, which is feet, which is how much of this stake that's going to be sticking out of the ground, I get 3.875 feet, which is really close to that 3.9 that I need. So as long as I can do that, I should be good, and I shouldn't have to make any measurements along here. I'll just need to pull it out and move it each time. I'm pounding this in with my sledgehammer. I started doing it on the raw board first, and it started to crack. Hopefully this will survive 5 poundings. So then I just put this up here and started hitting on this, so it would stop splitting the board. But I'm really close to where I need to be. Now my yard does have a little bit of drop to it. It's not perfectly level, but it shouldn't matter for this experiment. It should be okay. It's not that much, so it shouldn't affect the results too much. So now that that first position is set up, I'm going to stop for a while. It's going to be an hour or so before I come back out here and set everything up. Okay, so this is how I have to set my moon up. I'm on Dial-A-Moon. I picked this date and time for my reference. This is what I'm going to use. And this is how I'm going to use 2 a.m. Universal time, which is actually 4 hours ahead of me. I'm just going to use this one photo. I'm not going to change my moon relative to every 3 hours because it doesn't change that much throughout the night. So this is how I have to set my moon up. This is what it has to look like when I put it up on that post. So I'm going to go set that up for right now. And as you can see, Tycho here, it's about tilted about 5 degrees to the right. So, and it's about, you know, it's about 1/5 of the way up from the bottom. So I'm going to set my moon like that, and I'm going to keep it like that through all my observations. So yeah, I'm just going to keep this up, and as you can see, because I'm going to be here, so this one is not that far after moonrise for me. So yeah, that's what my moon is going to look like up on the post. So I'm going to go prepare that now. As you can see, my moon is ready to go. However, my Earth, the little tiny bit of wind we have, is just around this corner. So I've been thinking about this. That's where I'm going to be. Okay, and this is set for moonrise. This has to be tilted 23.5 degrees that way, and I'm at 47 degrees latitude, so my camera has to be tilted 47 degrees this way. And then the other angle we're going to have is the angle that direction towards the moon. Here's the problem. I cannot keep this on here. It just won't stay. I'm still trying to figure it out. If I can't, what I am going to do is I am going to set my camera 4 inches out here, take my first observation, move it 15 degrees this way, from the distance of the center of the bucket out 12 inches, do it again, then again, then again, then again. So I'll set the camera up here where my right foot is, I'll tilt it 15 degrees, rotation wise that way, and again, and again, then again for moonset. I'm still going to try to get this up, keep this from blowing over. But if I can't, then I guess I just can't do it. Now, in order to keep that 23.5 degree tilt, the camera will slowly, as you can see here, if I don't use the globe to line it up, it's going to come up higher. Okay, from moonrise to moonset as the Earth rotates. And that 10 degrees is easily compensated for. I can measure that easily. That other 10 degrees I talked about. So I might have to do it that way. So there's the camera. That's the camera I'm going to use. So I guess I should try to set this up, see if I can get my first observation or not. Okay, as you can see, the tripod's about 12 inches out. I can't use the globe. I'm really upset about that. And from where the bottom of our Earth would be, we are up about 10 inches. I'm going to have, or the camera lens is about 11 inches, sorry, my bad. And it's going to have to be moved up about 1/4 of an inch each rotation. So that's basically just to line it up. So here's going to be my first observation at moonrise. So I'm going to have to move it 15 degrees this way, and I have that to do that. So about 3 hours later, and I'm going to do it again, and we're about, I just have to stay 12 inches from the center, and I should be good. And we're going to record that here in a second. But yeah, really upset about that globe thing. There's just no way to keep it from doing that. And it's just me out here, so yeah. Okay, we're going to try this again. I had the brilliant idea of trying to put sand in here to weigh it down, but I started doing that. It's going to take way too long. So Sarah decided to try tape, and tape is going to work a lot better, I hope. And in order to see if I've got the 23.5 degree tilt, oh, sorry, other way. So it says it's 23. About, see if I have it. It's about 23 degrees. It's my bubble level. No, it's not. Wait, so it's close. It's close to 23.5 degrees. It's about as close as I'm going to get with this. So I can use it. So just going to need a few more minutes to set up here, put a little more tape down, and I'm going to have to pull it up and redo it every single time, but I think it's worth it. Okay. So we're projecting that way. This is probably not going to show up right on the camera, but if you put it up, it is. Yeah, it's not showing right on the camera. It's 47 degrees. It actually, I moved it. Do that. Just do that. Now we should be at 47. Yeah, you can kind of see it on the camera. I just put it right up there, and it's off a hair, but it's really close to 47 where it's supposed to be. So time is approaching here. Alright, let's do this here. There we go. I'm going to use this camera to actually record, and let's hit record and zoom in on our moon. And zoom in on our moon. Alright, this little crappy camcorder gets pretty good. Now the sun's kind of reflected off of it. As long as I can see some major features, we should be okay. So, let me try to stabilize that a bit. Alright. Right there. That's what I want. Right there. Make sure that's still at about 47 degrees. Oh, it's off now. Alright. There we go. But now, there we go. I need to move it a little bit to get the moon. Okay, so that's what I want. Now, the angle here, the bottom of the screen, that would be equivalent to my horizon. So the moon should look rotated that much to me at moonrise on March 30th, 2018. Now, let's go to the second one. As you can see, I moved the moon to position 2. Make sure it's zoomed out. So that's that one. Alright. Slowly zoom in on our moon. Wind just keeps getting worse. There wasn't supposed to be any wind today, and it just keeps getting harder and harder. I actually blew this off the stand. So I've taped it, I've reoriented it. There's with my dial-a-moon again. And, you know, Tycho is my reference here. About 1/5 to 1/6 of the way up from the bottom of the moon from my vantage point. So it should be looking like that. And I taped it on the back side. I didn't really want to do that, but see, in a couple of places. So hopefully that'll be enough to keep this from blowing off the stand as well, so it doesn't get destroyed. I think I can still do this. I just wish the wind would calm down a little bit because it's making this very difficult. Alright, now we are set up for observation number 3, which would essentially be lunar midnight, halfway between moonrise and moonset for me. Camera is set, you can see the UP right there. Obviously that's tilted sideways, so it will be. Alright, let's get ready for observation number 3. Now, before I do this, the camera from my globe, I took the globe off, the wind just keeps barreling too much. But I'll be looking at the moon this way from my 47 degrees latitude. Okay, I've upped the tripod another 1/4 inch. As you can see, it's moved over from it's in the middle observation point now. So my predicted altitude's between 40 and 45 degrees. So that means I'm going to be looking at the moon in that direction. And since I'm essentially at mid-lunar night, from moonrise to moonset, I'm going to kind of be looking straight on. So at this time, at 1:41 a.m. Eastern Daylight Time on the 31st, the moon should appear to me oriented as it kind of does on that dial of moon diagram. So it won't have a relative rotational tilt. I've talked about this before. So it should be, Tycho crater should be about 5 degrees tilted east from a center line if I were just to draw a vertical line from the disk of the moon as it appears in the sky. So let's zoom in so we can see if we can get any. Alright, I'm at 31 there. I can see some features. Where am I there? At about 40 there. I'm going to back it off a tad. That's 34. Let it focus for a second, and that'll be my relative, that's how the moon should appear to me in the sky at 1:41 a.m. Eastern Daylight Time on March 31st, 2018. Okay, we have 2 more observations to go, so let's get to those. Okay, I am preparing for observation number 4. Now, the camera's tilted at 24 degrees. That's my predicted altitude of the moon. My predicted altitude of the moon during observation number 4, which I'll get to. I'll show you the date and time when I actually start recording. It's going to be between 20 and 25 degrees. So 47 minus 23 is 24. So the camera's tilted at 24 degrees. Opposite of what it was when we did observations 1 and 2. 3, it was directly dead ahead because that was 90 degrees. So I've moved it another 45 degrees. So the moon, the Earth is rotating. Underneath it, that Tycho crater, that benchmark, is going to, at moonrise, 47, Tycho crater should be tilted about 47 degrees, from a random center line, if I would draw through the disk of the moon, and that would give me my latitude. Then about, around 24-ish at that second observation, almost dead center, it'll be tilted like 5 degrees, Tycho crater. In the middle, the last observation, now it's going to be this way, and our last observation, Tycho crater, will be tilted this way. That happens if the Earth is rotating as the moon moves in its orbit. As you can see, if the Earth didn't rotate, that wouldn't happen. Tycho crater would just go along this way. So we have, as you can see, it's in the middle, or it's in the 4th block. Tape measure was observation 1, then 2, then 3, and here's 4. So I'm going to set up for that with the camcorder, and we'll get to that one. Okay, this is observation number 4 for March 30th, 2018. Time would be 4:49 a.m. Eastern Daylight Time. Observation number 4. Okay. Let's start zooming in. That's 13 times. That's a lot of center. That is 42 times right there. See if I can get it to focus. And then that'll be my observation. Come on, focus. Let's try pulling in and pulling out. Doesn't want to seem to focus. Oops, I nudged it. There you go. Okay. That should be good enough. I can see features. It's just, Okay, this is going to be observation number 5. As you can see, our moon is set there. I'm going to do this in the camcorder. The battery on this just keeps dying. You can see we're at 5th location. I'm going to have to do observation 2 over again. I screwed up, but let's do this one first. Okay, this is observation number 5. Hopefully you can see that. Moon set will be at about 7:57 a.m. Eastern Daylight Time on the 31st. Now, the camera's tilted 47 degrees in the opposite direction. Because that moon's set, I'll be, in line with the horizon. So, my Tycho crater, my prediction is, since it was originally from Dial Moon tilted about 5 degrees to the right, from, an arbitrary center line, 5 degrees this way, my Tycho crater at moon set should be the 47 minus the 5, which would be 42 degrees tilted this way. Now, when I make these actual observations on the 30th and 31st, it is going to be weather dependent. So if I have clouds moving through or whatever, I might not be able to do these observations every 3 hours, essentially. It might be, one might be 2 hours and 45 minutes. So that's where the degree of margin of error is going to come in if I can't make these observations at these times. But let's zoom in and see what we get in our observation number 5. Let's see here. So remember, my horizon is going to be the bottom of my screen. That's 40 times right there. Camera should be set. It's kind of moving less a little. That should be 47 degrees right there. Now you can't see Tycho crater here because it's below my plastic base, but there's other reference points on the moon I can use to figure out where Tycho is. And if this thing would stay for half a second, and if the wind would die down, we should be able to get this. There we go. Zoom in a hair more. That's 50. That's 35 times. Just keep it there for a second, then I'll turn it off. Alright, this should be good. Okay, so this is the setup for my redo of observation 2. My camera is really close to 24 degrees. It's not perfect, but it's close. So this is basically the exact opposite of observation number 4. And the reason why I'm redoing this is for a couple reasons. This is the observation that the wind blew the globe off, or the moon globe off. We have less wind now, but my Earth is tilted correctly. Okay. Moon is reset up, as you can see, at position number 2. So I'm going to re-record this. The camera is about 4 inches out. I should probably move it a little bit closer because the lens is more than 4 inches out. So it needs to be as close to that 4 inches as it can. I don't think I can get the tripod any closer. So let's do that. Let's see if we're anywhere near 4 inches. That should be easy. Yeah, we're close. Okay, and there's my position, so I'm close to it. This would be rotated 45 degrees from our initial observation 1, so we're 45 for observation 2. Observation 3 was at 90. Observation 4 was at 135, 45 plus 90, and then our observation number 5, that was observation 4. Observation number 5 is 180. Our moon set is 180 degrees from our first observation. All right, so I'm going to get this started now, I think, and this will be the final one. Alright, wait, let me zoom out all the way. There we go. If you can see that. So it's Earth Moon to scale, model for the night of the 30th. It will be on the 30th, 2018, observation 2, take 2. Time is 22:33 Eastern Daylight Time. Alright, so let's do this. Oh, actual time right now for this retake is 14:01 for the actual time on the 25th. Alright, so let's start zooming in. Alright, remember bottom screen would be equivalent to my horizon. Alright, let's rotate it a tiny bit. We're at 25 zoom now. Let's get a little closer. It's 31 zoom. That's 42 zoom. Hopefully it'll stabilize for a second so we can see features. That's another thing too, the video from the original take 2 wasn't that good, it wasn't that focused. But there's 59 zoom. I have no remote zoom on this, I have to do it manually. So that's 44, we'll leave it there a couple seconds, and then that should be it. Okay, I think that's good enough. Okay, we are in the home stretch here. What I'm going to do now is take photos from the camcorder footage I already showed you when I recorded from each of the 5 observations, and I'm going to mark some points on there and make some predictions. Okay, remember, when you do something like this, you need to also think of how you could have messed this up or how you could be wrong. That's a very important part to doing this. Alright, I've made the physical observations. Now I need to make a prediction, which I'm going to get to at the end, and then I need to discuss how I could be wrong, which I'll wait to do till the end. But anyway, here's observation 1, raw photo. On all these, you'll see the raw photo, and then you'll see me crank up the contrast and pull down the brightness so I could see features. Now here, I've marked some of the craters. Alright, now observation 1, and then there's going to be a problem with it, but then I just put a circular disc with crosshairs over it, over the moon, and I'm drawing a line, and I'm going to show you the arrow, but this one has a problem, and I'm kind of annoyed with this, but I think that angle there is actually 39 degrees. I was looking at this photo, and I realized that Grimaldi is way off, and kind of Tycho is too. So I took my Dial-A-Moon photo, there's the date and time that I discussed earlier, and as you can see, I'm off a lot. I'm off 3% from Plato, I'm off 8% on Tycho, 6% on Grimaldi, so my moon was oriented incorrectly for this. So, and then when I did the second observation, it would have been the same, but then I had at first I was annoyed when the wind blew this off, but it gave me the opportunity to reorient it, and redo observation number 2, and that's what you're going to see here. You're going to see observation 2 next, the take 2. All right, raw photo. So here's Grimaldi and Tycho. So I did the same thing here I did with the first one to make sure I was close. I got 16% for Tycho. That's close to the 18%. I got 4 for Grimaldi. That's close to the 3%. I couldn't, for some reason, I couldn't draw Grimaldi. I couldn't highlight it correctly. When I do this, I put a photo in the publisher. That's how I do this, and then I draw over it. So for some reason, just Grimaldi. It works for all the other ones, just this one for some reason. I don't know why. But anyway, our crosshairs, I draw my angle. I get 22 degrees. So during my second observation, which will be at that time, which was, I believe, hold on, I gotta get this out. Sorry about that. I think it was that second observation, when I do it this weekend, will be at 22:33 Eastern Daylight Time. So that's how my moon should look to me if I take it at that time, plus or minus 5 degrees, according to my model. All right. Here's 3, observation 3. We do the same thing. Tycho Grimaldi. Do our crosshairs. Tycho craters should be about minus 1 degrees. Now, when I say minus 1 degrees, that's to the left. When I'm using positive numbers, it's to the right. When I'm using negative numbers, it's to the left. So everything after this point is going to be a negative number, plus or minus 5 degrees. All right, now I know my moon is oriented correctly for the rest of these observations because I taped it. So it didn't move. The wind didn't move it at all. Okay, so here's observation 4, raw photo. Grimaldi, Tycho, and then this is probably the best photo I pulled from any of these. So let's draw our thing. We get minus 20 degrees, plus or minus 5 degrees, and I'll explain at the end why I have that plus or minus 5 degrees. Actually, I've touched on it before. It's my margin of error. Because doing this, and especially with how windy it was, there is going to be a margin of error. So as long as I'm within that frame, but there could be something else that could mess this up, which I'm going to get to at the very end here. And so here's our final observation, number 5. This will be close to moonset at about 7:57 on the 31st. So we do that to get the craters. And I get minus 49 degrees, plus or minus 5 degrees. So that's my prediction there. All right. So basically, here's a summarization of my observations. I can't use number 1. It's invalid. So I've got 4. I don't have the time right now to reset up the experiment to redo number 1. So, and my plus or minuses, these are my predictions. I have predicted azimuth, the altitude, which is how high the moon will be from the horizon at that azimuth, and relative rotation of Tycho from the center. Because when I take photos of the moon, when I put this in and compare them, I am actually going to use Tycho as my reference point. Now, for observation 2 through 4, I looked in my model, my altitude was based on the relative angle of the camera, so it's a physical measurement. If my altitude is off, like say observation 2, say the altitude isn't between 20 and 25 degrees, say it's like 30 degrees, obviously that's going to mess with Tycho. But I have not looked at date and time to confirm this yet. I don't want to do that. I did look up moonrise and moonset, but not on dateandtime.com. But I have not looked at it yet because I wanted to see, I didn't want to be biased when I made these measurements. So there's my observation summary. I think that's pretty much it. If you have any questions or need clarification, please ask them below. Please like and subscribe, and I hope you learned something.